Hello all, today we are going to see the topic sound. In physics, sound is a mechanical or material or an electromagnetic wave. It is very important that most of the times it is being repeated in RRB JE exams as sound is a form of which energy? It is a form of mechanical energy which is also called as material energy, or it is a non-magnetic wave. This has to be highlighted. This is very important and has to be remembered. Okay, sound is a form of energy which is emitted by the vibrating particles. Every vibrating particle produces sound. The sound takes 1 by 10 seconds to travel. Velocity of sound in air at room temperature is 343 meter per second, and at 0 degree centigrade it is 331 meter per second. Those don't confuse, these two are very important. At room temperature it is 343 meter per second, and at room temperature at 0 degrees it is 331 meter per second. When it comes to materials, materials are of two types: soundproofing materials or sound producing or generating materials. Soundproofing materials are used to control the sound, whereas sound producing or generating materials are used to produce the sound. What are the soundproofing materials? We already know: wood, plastic, coconut shells, thermocol. All these we use in the places where we need to control the sound, when we need to reduce the sound and all. When it comes to producing materials, we all know that all metals produces sound. All alloys, crystals, diamond, these are the sound producing materials. Next is waves. Waves are of two types: electromagnetic waves, mechanical waves. Electromagnetic waves are also called as non-material waves, whereas mechanical waves are also called as material waves. What are the examples of mechanical waves? Sound. Sound is an example of mechanical wave. As we read earlier, sound is a form of mechanical energy, so it produces mechanical waves. Okay, sound needs medium to travel, whereas light does not need any medium to travel. Sound cannot travel through vacuum, and it needs any medium to travel. What are mediums? Solid, liquid, gases are the mediums. It's only sound can travel through any medium. It cannot travel through vacuum. It should be highlighted. Okay, next, in electromagnetic waves no medium is required. I already told you sound cannot travel through vacuum, whereas light can travel through vacuum. So light cannot need any medium to travel. When it comes to types of mechanical waves are of two types, which are longitudinal waves and transverse waves. Let us see the longitudinal waves. Applied force parallel to the generated waves. See, the applied force is when it is parallel to the generated force, then this is called as longitudinal waves. Which is the example of longitudinal waves? Velocity of sound in air. When the sound is traveling which is parallel to the air, sound and air are traveling parallel to each other, then it is called as longitudinal waves. Whereas transverse waves are different from the longitudinal waves. It is opposite to the longitudinal waves. When we compare, when we take a crust and a trough, this is called as node. This is one node, this is one node, and this is the center of the crust is antinode. The difference between two antinodes is lambda. The distance between the two antinodes is lambda, whereas the distance between an anode and an adjacent node is lambda by 4. When the distance between two antinodes is two adjacent antinodes is lambda by 2. Lambda by 2. Distance between two antinodes is lambda by 2. What is wavelength? Wavelength is the distance between two successive crust or tufts is called wavelength. Wavelength is denoted by the letter lambda. The distance between the crust, two successive crust, or the distance between two successive troughs, it is called as wavelength. Wavelength is denoted by lambda. Here we already mentioned that the distance between two antinodes is lambda. That is nothing but the wavelength. When it comes to frequency, frequency is the number of oscillations per 1 second. The number of oscillations taken per 1 second, it is called as frequency. Frequency units hertz or cycle per second. Cycle per second is also called as hertz. Next, amplitude. The maximum displacement of a vibrating particle from its mean point, from its mean position, it is called as amplitude. Male voice has high amplitude, whereas female voice has low amplitude. In female voice we have low amplitude, high pitch. In male voice we have high amplitude, low pitch. We should remember this. This is very important in case of exam. We already discussed sound needs medium to travel. In which medium sound travels more fastest? In solid medium sound travels more fastest. In liquid medium it is faster, whereas in gas it is fast. This has to be remembered. In which medium the sound travels the most is solid, the least is in gas. Okay. Vacuum means where there is no space. Does sound travel through vacuum? No, sound cannot travel through vacuum. Example is moon. V of sound at moon is always 0. The study of moon is called serenology. You should remember this, serenology. Next, infrasounds, audible sounds, ultrasounds. This is one of the most frequently asked question. This part is very important and should be remembered. Infrasounds are generally, what is the audible range? First of all, we should remember the audible range. Audible frequency range is 20 Hz to 20,000 Hz. Audible frequency range. So if it is less than 20 Hz, it is called as infrared sounds. If it is more than 20,000 Hz, it is called as ultrasounds. The animals which can hear infrared sounds are whales, elephants, rhinoceros, carpi, alligator and giraffe. What is meant by alligator? It is a crocodile. Okay. Next, the sounds which are more than 20,000 Hz, it is called as ultrasounds, and ultrasounds can be heard by bats, whales and tortoise. That's why in previous days bats are used to navigate the echolocation. Okay. Next, ultrasound generation. Ultrasound generation can be done by two methods: piezoelectric effect or material used which is quartz. Quartz is used to find out the ultrasound generation. When it comes to applications of ultrasonic sounds has many applications. It is the range of the sound when it is more than 20,000 Hz, 20k Hz, it is called as ultrasounds. What are the importance of ultrasounds and what are the applications of ultrasounds where we are using? For example, the most well-known application of ultrasound is sonography. What is sonography? To produce the fetus in a human body in the mother womb. And for purification, UV rays or piezometric methods are used, and pasteurization of milk. And in LRAD, long range acoustic device, also we use the ultrasounds only. These are all the applications of ultrasounds. The treatment of arthritis, to remove the broken teeth without any surgery, we also use the ultrasounds only. Okay. When it comes to sonar is very important. What is sonar? Sound navigation and ranging system. Generally we use Nixon. Okay. 2D is equal to VT, D is equal to VT by 2. What is resonance? Resonance is the result of forced vibrations in a body. When we swing breaking wine glass by sound. These are the examples of resonance. Okay. Next is echo. What is echo? Reverberation. Echo and reverberation are very important. Echo is reflection of sound, whereas reverberation is the time interval in which the intensity of sound is again produced. Okay. Echo, applications of echo and applications of reverberation are very important and you have to remember. Echo is stethoscope. Echo is used in the principle of stethoscope, megaphones, horns, musical instruments like trumpets and shanays. Next, factors affecting the sound. Next, factors affect the speed of sound. Speed of sound depends on temperature, density, humidity, elasticity and directionality. Whether it is directly proportional or indirectly proportional, let us see. Temperature is directly proportional to the speed of sound. Okay. Next, density is inversely proportional to the speed of sound. These are the main points which has to be remembered. And next, humidity. If humidity increases, density of the sound decreases, whereas speed of the sound increases. So if humidity increases, speed of the sound also increases, which means directly proportional. When it comes to elasticity, speed of sound depends on elasticity. Elasticity is equal to ability to bounce back to its original position. Okay, so elasticity is more in solids compared to liquids and gases. Pressure is not dependent of speed of sound. Next, directionality of the air. If the direction of the air and the sound waves are in same direction, then velocity, speed of sound is more. If the air and the sound waves are in opposite direction, then speed of sound is less. If the air and sound waves are in same direction, then speed of sound is more. If they are in opposite direction, then speed of sound is less. What is Mach number? Mach number is the velocity of an object by the velocity of sound in air. Velocity, for example, velocity of the object is 1000 meter per second. We know that the velocity of sound in air is 343 meter per second at room temperature. So the Mach number will be 1000 by 343, which is 4. 4 is the Mach number. The type of velocity and velocity of an object. Type of velocity is subsonic, which is less than 1. Sonic is equal to 1. Supersonic is between 1 to 5. Hypersonic is between 6 to 10. High hypersonic is more than 10. This has to be remembered. Next, what are the characteristics of the sound waves? Sound waves characteristics are 3 types. The sound waves depends on intensity of the sound, pitch of the sound, quality of the sound. Intensity of the sound is directly proportional to A square, which is depends on amplitude. It measures the sound pollution. Sound pollution more than 80 decibels, then it is if the sound is more than 80 decibels, then it is called as sound pollution. The most noise polluted city is Dhaka. Remember this is important. And when it comes to measurement of the noise, the intensity of sound is measured in terms of pressure level and common unit is decibels. This is not required, and this is the what we have to remember. At daytime and night time in the particular industrial area, commercial area, residential area and silence area. There is a shortcut for this. We have to remember the industrial area daytime is 75, then minus 5, minus 10, minus 10, minus 10. In vertical wise, in row wise, minus 10, minus 10, minus 5. But horizontal wise, reverse, minus 5, minus 10, minus 10, minus 10. Okay, 75 minus 10 is 65. 65 minus 10 is 55. 55 minus 5 is 50. Here now we have to reverse the order. Then 75 minus 5 is 70. 65 minus 10 is 55. 55 minus 10 is 45. 50 minus 10 is 40. Is this clear? First we have to remember 75 decibels. Okay, next is pitch. Pitch of the sound depends on the frequency of the sound wave. If there is low pitch, then the frequency is also low. If there is high pitch, then the frequency is also high. We have seen the characteristics, intensity of sound and pitch. Intensity of sound purely depends on the amplitude, whereas pitch of the sound purely depends on the frequency. Okay, frequency. Next, quality or timbre. Sound quality or timbre describes those characteristics of the sound which allow the ear to distinguish between the sounds having the same pitch or and loudness. This quality of timbre differentiates the sounds between them having the same pitch or loudness. Next is Doppler effect. These Doppler effect applications are very important and frequently asked in many of the questions. The increase or decrease of frequency of sound or light waves is the relative motion between the sound of the wave and its receiver. Example is speed gun, sonar, radar. To determine the direction of the self-rotation of the sun, use Doppler effect. To hear the heartbeat of the fetus. Fetus means a baby which is in mother's womb. Echocardiogram. Echocardiogram is also based on the principle of Doppler effects. Using this, we can know the velocity of blood flow which is flowing through the veins and arteries in the heart. With the help of sonars, the military uses the to determine the speed of their submarines also. Submarines also use this Doppler effect. These are the topics which we have covered, and these are the questions from the previous year papers. Just go through it once. Take a screenshot of it and revise. These are the applications of sonar. Thanks for watching the video. Please do like, share and subscribe to our channel. Thank you.